Hello and welcome back everybody. As you all know, I am Kirti, your chemistry educator, and today we are going to start with a very fundamental topic which is definitely going to help you in organic as well as inorganic section. Alright, but before beginning, let me ask you, how are you all? I hope you all are doing great, amazing and having a lot of fun. But today we are going to do a little bit of study in which we are going to deal with this. So let's get started. Here it is. So what we are going to study today? First of all, let me give you a brief introduction about chemical bond. Alright. So let's get started with this slide. Although here it is written ionic bonding, but before that we are going to study what do you mean by a chemical bond. So let's see. Here it is. If we see a chemical bond, alright, this word bond simply means a kind of force because of which two atoms, molecules, ions, compounds are combined with each other. As simple as that. So it means simply a force. What does it mean? It just simply means a force. That is it. Now, we need to study. Alright, listen to me. We need to study only three types of bonds. Number one is the ionic bond. Ionic, iska alternate name. Its alternate name is electrovalent bond. What is it? It is electrovalent bond. Alright. So this will be our main mudda in this particular meeting. What? That will be ionic or electrovalent bond. But in our further sessions, we are also going to deal with number 2, covalent bond. What? Covalent bond. And number 3, coordinate bond. What is it? Coordinate bond. Alright. Again, I am not saying these are the only 3 types of bond which exist. Indeed, I am saying that these are the 3 types of bonds which we need to study. So mind it, alright. So let's get started with our ionic or electrovalent bond. So as the name suggests. Itself ionic. What does it mean? That it will be made up of ions. As simple as that, it will be made up of ions. So let's get started. Alright, let's go into the depth of this session. So we will discuss it, say here. Alright, we'll discuss it, say here. So ionic bond will be present where there will be a metal and a non-metal. Now you guys are going to tell me what metals are and what non-metals are. This job is yours, definitely yours. I hope you have studied it in junior classes, metals and non-metals, very basic, correct? So ionic bond is always present where we have a metal and a non-metal. So wherever you have a metal plus a non-metal, you will have which bond? Ionic bond. No need even to think. Metal plus non-metal, you will definitely going to have ionic bonding. Simple. Now, how? Right? What is this bond? So, you guys have studied that in case of metals, what is their tendency? They have a tendency to lose electrons. So, metals have a tendency. Let's use a different color. Say red. Alright. So, metals have a tendency to lose electrons. On the other hand, what is the tendency of non-metals? It is to accept electrons. So non-metals have a tendency to accept electrons. Accept, or you can say gain electrons, right? Now this was the number 1 thing. What is number 2? The octet rule. What does it say? Simply according to the octet rule, if an atom wants to achieve stability, right, it wants to get stable so that nobody could destroy it. So in order to get stable, in the outermost shell, which means the valence shell, always remember the outermost shell is called the valence shell. So in the valence shell, there should be 8 electrons. Which rule? Let's see. It was our octet rule we were talking about. It was octet rule. As the name suggests, oct. Oct means simply 8. Octopus, which has 8 legs. Octagon, which has 8 sides, right? So similarly, octet rule, such that the atom's valence shell has 8 electrons. The outermost shell means the valence shell has 8 electrons. Alright, so what happens? It will gain stability. Now, let's come back to our metals and non-metals. In the valence shell of metals, we have either we have either 1, 2 or 3 electrons. Wait for a while, right here. Let's write it again. So we'll have either 1, 2 or 3 electrons. Alright. But in the case of valence shell of non-metals, we will have either 4, 5, 6 or 7 valence electrons. Alright. What will happen? What is going to happen if there is only 1 electron in the valence shell? If it donates it, and the same electron is accepted by the non-metal, so that one will become positive charge and the another one will become the negative charge. Let's see how by using the examples. Alright, so the first example we are going to discuss is the formation of sodium chloride. What is it? The formation of NaCl. The formation of sodium chloride. Sodium Na, कितना होता है atomic number? What is its atomic number? Here it is sodium. Its atomic number is 11. What is it? 11. So what will be its electronic configuration? Electronic configuration would be what? 2, 8, 1. Right? Now, as you can see, sodium is a metal, only 1 electron in its valence shell. Now comes the chlorine. It has how many electrons? What is its atomic number? It is 17. So that its electronic configuration would be 2, 8. 10 are done, rest are 7. Again, it has 7 valence electrons. Now what will happen? In order to attain stability, this valence shell electron will be donated here. What will happen then? It will achieve its octet in order to get the stability. It will also attain octet. It will also have 8 electrons, so that it will also gain stability. Right? So what will happen? The octet rule will be followed, and as a result, both of them will be stable. Now let's look in the terms of equations. Let's look in the terms of equations. So when it comes to sodium, Na, it was our sodium. Now you guys need to remember one thing. What is it? That whenever a metal atom, usually a metal atom, loses its electron, whenever some atom, some molecule loses its electron, it gets a positive charge on itself. You guys can remember it as, you can say, what? Whenever you donate something, you get to have a positive energy, something positive in you. So this Na, when it loses an electron, it becomes Na positive. What does it become? Na positive. And what did it do? It loses an electron. So here it is. Alright. Now this Na positive, the sodium atom having a positive charge, it is called a cation. What is it called? It is called a cation. Simply called a cation. Now let's come to chlorine. Now let's come back to chlorine. Since this chlorine now will accept the same electron which sodium has lost. So this electron will be gained by this chlorine, and as a result, when you keep something, it will get a negative charge. When you donate something, you get something positive. But when you accept something, you get a negative charge. So it will simply become Cl negative. Now this negative charge is called anion. What is it called? It is called an anion. It is called an anion. So now what happened? We got two ions. What were they? Number one, it was Na positive, and number two, it was Cl negative. Right? Now you have one positive charge in the one hand and you have a negative charge in the other. What will happen? A positive and a negative will always attract each other. Always. Remember it. Alright? The opposite charges attract each other. Definitely. So they will have a strong force of attraction, which is called electrostatic force of attraction. What we'll call it? We'll call it electrostatic force of attraction. Electrostatic force of attraction. Force of attraction. And always remember that it is very strong. It is very strong force. So this is very strong. So simply now this attractive force is named as, it is called as an ionic bond or an electrovalent bond. Why? Ions are formed, Na positive and Cl negative, so it simply becomes an ionic bond. Alright, so a very good concept. I hope it is clear to you. And here we have a diagram as well, in which we have saw you that the formation of how NaCl is formed more precisely. So here Na has 11 electrons, chlorine has 17 electrons. The outermost valence electron has been transmitted to the chlorine. As a result, the bond is formed, which is simply called an ionic bond. That is it. Alright. So I hope this concept is clear to you. Now let's look at the second example. What is it? It is the formation of MgCl2. This is the formation of MgCl2. Again, now let's do it quickly. Magnesium, what is it? Atomic number? It is 12. What is it? It is 12. So its electronic configuration would be 282, right? Now it has 2 electrons in its outermost shell. If we bring chlorine, again atomic number 17, what would be its electronic configuration? Simply 2, 8, 7. But now it's just going to accept 1 electron. But we can bring another chlorine, as simple as that. So another chlorine, again 17 is its atomic number, and it will become 2, 8, 7. Now out of these 2 electrons, what will happen? 1 electron will be donated here and 1 electron will be donated here, right? Yahan par bhi the octet will be completed, and here also the octet will be completed. So that's how it works. Now let's look at the chemical equations. And then we'll discuss a small concept as well. So here it is, magnesium. What will happen? It is losing electrons. So it will get which charge? Tell me, which charge? Positive charge. How much? 2 positive. How much? 2 positive. Why? Because it lost 2 electrons. So plus 2 electrons we got. Now these same 2 electrons will be accepted by 2 chlorines. Always remember, that's how we balance the equations. Correct? So it will be 2 chlorine will come and they will accept these 2 electrons and 2 Cl negative will be formed. Alright. Now let's discuss a very small concept, not related to this chapter particularly, but it will definitely going to help you in your competitive exams. So let's see what is it. See, whenever the electrons are lost, that process is called as oxidation. That process is called as oxidation. And whenever electrons are accepted, that process is called as reduction. What is it called? It is known as reduction. Now, as we can see in the formation of an ionic bond, let's see in the next slide as well. Here, electrons are being loose. So, it will be oxidation and this will be reduction. So, wherever oxidation and reduction happen to take place simultaneously. How simultaneously? Oxidation is happening and reduction is also happening. So whenever there is oxidation plus reduction, that type of reaction is called a redox reaction. What is it called? Redox reaction. Red stands for reduction and ox stands for oxidation. Together it form a redox reaction. Correct? So you can say the formation of an ionic bond or electrovalent bond in itself is an example of redox reaction. Alright, so I hope we are it's quite easy to understand what is an ionic bond. We are done with it. Now quickly we are going to discuss its properties. What are they? Let's see the properties of ionic compound. Now the first one says ionic bonds are very strong. But before discussing all of these properties, what are we going to do? What are we going to do? I am going to tell you the father or the god of all these properties. The father of all the properties. What is it? It is that in ionic bonding, we have strong electrostatic force of attraction. We have what? Strong electrostatic. We have strong electrostatic force of attraction. Force of attraction. Right? Now, how is it the father of all the properties? Let's see. So the first one says that these bonds are very strong. As in itself, the force is very strong because of which the ionic bonding is being formed. So if the bond is strong, quite obvious that these bonds will be very strong because of strong electrostatic force of attraction. The second one says that these are solids at room temperature. Generally, they exist in the solid form, right? Again, if you can say if the force is very strong, one positive charge and one negative charge, very strong force of attraction, they will be like this. So what form, what packing? बहुत high packing, high density packing. As a result, it will automatically get in the form of a solid, है ना? If two atoms have a low force of attraction, they may exist as either liquid or gases depending upon the magnitude of the force of attraction, right? But here we know that the magnitude of force of attraction is very strong, very high. So what will happen? It will automatically exist as in solid state, right? So let's see further. Again, have high melting and boiling points. If anyone asks you the reason, what is it? Because of strong electrostatic force. Now again, if you have such strong forces of attraction, what will happen? What is going to happen? The compound which has ionic bonding in itself, it is not going to melt easily. It's not going to boil easily, right? Because whenever you melt or boil something, you need to break the bonds between them, right? You already have such strong forces such that they are very difficult to break them down. It's very difficult to break them down, right? So as a result, they will automatically have a high melting and boiling point, quite obvious, no? Next, made of metal and non-metal. This we have discussed in the beginning, that one will be metal and the another will be non-metal. Long story. Metal will lose electrons, non-metal will accept electrons, octet rule, and the formation of ionic bonding. This we have already done, correct? I hope this is clear to you. Let's move on to the next part, which says, quite important, that these compounds which have ionic bonding in them, they do not conduct electricity in the solid form. In the solid form, see, does not conduct electricity in solid state. Why? See, if you have NaCl, let's see, if you have NaCl solid, it definitely has some ions. It definitely has ions. That is Na positive plus Cl negative. It has ions. But these ions are not free to move. What is the problem with these ions? They are not free to move. Not free to move. This is the problem with these ions. But the moment you melt them, or in the aqueous form. What do you mean in the form of aqueous form? It means that they are dissolved in water. You can say the salt in your home, NaCl, Tata Namak, it is not conducting in the solid state. But if you dissolve it in water, it becomes a great conducting liquid in the aqueous form. Why? Because when you melt them or when you dissolve them in water, they become great electricity conductors. All right, the last point would be, let's add one more. What is it? The last one would be solubility, that these compounds are soluble in water, soluble in polar solvents. Instead of water, let's write polar solvents. Let's write polar solvents. It means they have poles, one positive and one negative. If you look at this NaCl, oops, we have some issue. Wait for a while. Here it is. This was Na positive plus Cl negative. All right. So if you look at them, these ions, one positive and one negative, it is creating a pole, right? So like dissolves like, polar thing will be soluble in the polar solvents. So you can say these are soluble in polar solvents, but insoluble in non-polar solvents. All right, that's it. Now we are done with the properties of ionic compounds. Let's move further, which is the conditions for the formation of ionic bonding. Means in which circumstances, in what conditions the ionic bond will be formed. Our very last topic, and then you guys will be done with this small teeny tiny concept, that is ionic bonding. All right, so let's see conditions for the formation of ionic bonding. Number one, as we know what, that metal is involved and non-metal is involved. So when it comes to metal, we know that it has a tendency to lose electrons. So it should have low ionization potential. It should have low ionization potential. Low ionization potential. What does it mean? Ionization potential is simply the energy required to extract that electron. So lower the energy is required to extract it, the faster the electron will be extracted. Very simple. So the first condition is lower the ionization potential of the metal atom, faster the bond will be formed. Correct? And we know the second thing, that is non-metal. Now non-metal has a tendency to accept electrons. So it should have high electron affinity. It should have high electron affinity. Now what does it mean? Since we want the non-metal to accept the electron as faster as soon as the metal donates it. So non-metal should have a strong desire to accept the electron, that is high electron affinity. Simple. And the third one is the metal and non-metal. There should be definitely major electronegativity difference. क्या होना चाहिए बच्चे? Electronegativity difference. Electronegativity difference. This should be present. Alright. So here are all the conditions for the formation of ionic bonding. And you are done with it. And what else we have? Simply thank you for watching. I hope you enjoyed it. I hope you learned something new today. Correct? So hope to see you again. Keep practicing and all the best. See you soon.